Balancing chemical equations. Look at this chemical equation. Fe plus H2O gives Fe3O4 plus H2. It is a skeletal equation. So you have to balance it in order to satisfy the law of conservation of mass. Let us see the stepwise balancing of this skeletal equation. The first step is draw boxes around each formula of each reactant and each product. Now the reason for drawing boxes around the formula is that when you are balancing a chemical equation, you are not supposed to touch the formulas. You are not supposed to change the formulas. Whatever balancing is done, it is done outside the box. Now the second step is to count the number of atoms of each element on the reactant side as well as on the product side. Let us start counting. First we start with Fe. Fe on the reactant side is 1, whereas on the product side it is 3. Then let's go to hydrogen. Hydrogen on the reactant side is 2 and on the product side also it is 2. Then oxygen. Oxygen on the reactant side is 1, whereas on the product side it is 4. So in short, we can say this is an unbalanced equation. Now from this table, you can identify the element which has most number of atoms. It is oxygen. So in the third step, we will start balancing the element which has the most number of atoms. Now while balancing, you have to remember that balancing only includes multiplication. Let us try balancing oxygen now. Oxygen initially on the reactant side is 1, whereas on the product side is 4. Now you have to balance the oxygen on the reactant side. For that, we have to multiply that one oxygen 4 times so that it becomes 4 oxygen. So, to balance oxygen, we have to multiply the entire chemical formula of water by 4. So, we write 4 ahead the box of H2. Okay, now, while balancing oxygen, something else got disturbed. That is hydrogen on the reactant side. When you multiplied 4 to H2O, hydrogen became 8. It was already 2 and you multiplied 4. So, now you have to balance hydrogen on the product side. The product side, hydrogen is only 2 initially, and on the reactant side initially it is 8. So we have to balance the hydrogen on the product side by multiplying it by 4 so that it also becomes 8. Okay, now which element is left to be balanced? Iron, that is Fe. Fe on the reactant side is only 1 initially and on the product side is 3. So you have to balance the Fe on the reactant side. So we multiply that 1 Fe by 3. So finally, we have to check the correctness of our equation. Now our equation has become 3Fe plus 4H2O gives Fe3O4 plus 4H2. So is our equation correct? Is it balanced on the left and right side? Yes, it is. But now if I look at the equation, I feel there is something missing here. If you see H2O, that is water, do you know which state it is taken in? Is it taken in the liquid state or is it taken in the gaseous state or solid state? We do not know because this equation is right now incomplete. So, for making a chemical equation more informative, we have to write down the physical states of each and every reactant and each and every product. Now, physical states can be solid, liquid, gas or aqueous. Now, if a reactant or a product is in solid state, we have to write a small s besides it. If it is liquid, then small l. If it is gaseous, then small g. And if it is aqueous, then small aq. Aqueous is which state now? Now sugar is in solid state, but if you dissolve it in water, the state of sugar becomes aqueous. So anything dissolved in water becomes aqueous. Okay, so in our equation, Fe, which is iron, is solid, so we write S besides it. Then here H2O is taken. It is water, but here in the reaction we are taking water in the gaseous state, so we write G besides it. It forms Fe3O4. It is kind of a salt, so it is again solid. And it releases hydrogen, so hydrogen is a gas, so we write G there. Okay, and now the next step will be, if there is any condition required for a reaction to take place, we have to write down the condition above or below the arrow. For example, the conditions can be temperature or pressure or catalyst. We have to write down the information about them above or below the arrow. Now, what is a catalyst? Catalyst is a substance which changes the rate of reaction, but it doesn't take part in the reaction. Okay, now let's take some examples. Carbon monoxide reacts with hydrogen and forms methanol. Now in this reaction, pressure is required, 340 atm, so it is written above the arrow. Similarly, during photosynthesis, carbon dioxide and water is absorbed by plants and they form glucose and oxygen. Now in this process, sunlight and chlorophyll are essential, so they are written above and below the arrow.